Welcome back to the channel. This is the Earth Science Classroom. This video is on atmospheric chemistry and environmental science. This video will be discussing VOCs, what they are, where they come from, and why they are harmful in large quantities in our troposphere, how they chemically react in the atmosphere, and the eventual pollutions or pollutants they can create when they're in the atmosphere. This is the Earth Science Classroom. VOCs is an acronym. The V stands for volatile, the O stands for organic, the C stands for compounds. Now, a compound in chemistry is a molecule that has multiple different elements in the chemical composition. So these can be naturally occurring and also man-made or anthropogenic. And when you have the term organic in a chemical composition, that somewhere there must be a carbon element in the mix. Let's begin with some chemistry and looking at vaporization, which is to do with the first letter of VOCs, which is V, and that stands for volatile or volatility, and that refers to a liquid substance containing different chemicals or molecules. The ability for a substance or molecule to turn from that liquid material or liquid phase in chemistry and turn into the gas phase and become a gas and become vapor. And this is to do with evaporation, which usually occurs on the surface of that liquid medium or liquid substance, and you have energy being applied or inputted into this liquid through higher temperature, which equals higher particle energy. The particles will move more, and based on the chemical bonding, the composition, and also the strength of those chemical bonds, which is called intermolecular forces, depending on the strength of the bonds, how that energy is going to interact with the particle and how the particle is going to interact with its bonds will define or dictate whether that molecule will break the bonds and evaporate and go from the surface of the liquid and enter the atmosphere as a gas, which is termed vaporization. The ability for a liquid to become vapor or gas, which is involved with a change of energy, the breaking of bonds between the molecules, and also the temperature and the atmospheric pressure. Now, if a molecule or substance is easily evaporated, easily turned from a liquid to a vapor, we call this volatility. So these volatile compounds, which are organic in nature, has a carbon in its composition, these are easily evaporated from a liquid into a gas. Now, generally, this is how we get smell, experience a smell from a certain substance or material or chemical. That smell you're experiencing through your nose and your senses is the released or vaporized molecules from that liquid into the atmosphere as a gas. For example, you go and fill your car up with gasoline or petrol. That smell you get when you are fueling your car is that benzene. It's the benzene from the gasoline or petrol that has been vaporized and it's volatile and escaped from the liquid and enters the atmosphere, and you can smell it in the atmosphere around the gas station or the petrol station. Now, I personally love that smell, but that is vaporization. That is the benzene evaporating easily and breaking the bonds from the gasoline or petrol and entering the atmosphere as a gas, and we experience that as smell. So what are the characteristics of VOCs, volatile organic compounds? So they originate from both natural and man-made chemicals. They're a large chemical group, contain multiple different chemicals, multiple different elements and bonding and organization, and they are really a large array of different elements, different chemicals, and they are emitted directly into the atmosphere, so they are a primary pollutant. These gases have a high vapor pressure, which goes back to the previous slide where we discussed the ability for these compounds and molecules and substances to easily evaporate. That refers to high vapor pressure. And these VOCs, once they enter the atmosphere, are highly photochemically reactive. So the ability for the sun's energy, the photons, through the atmosphere to chemically break down and slice apart these chemical bonds, taking these compounds and breaking them down into smaller molecules, mostly free radicals or hydroxyl radicals. And these VOCs are low water solubility, which means that they don't easily combine chemically with water, so they don't want to mix with water easily. So these aren't going to be involved with the water cycle and condensation into clouds. These are going to be separated from the water vapor as they hang out together in the troposphere. And these VOCs are divided into three categories or three divisions. There's very volatile, there's volatile, and there's semi or semi-volatile, based on the ability for these compounds to both evaporate and also chemically react in the atmosphere. VOCs are an extremely large group of chemical compounds containing carbon, which refers to the organic, and they come in different lengths of hydrocarbon chains with different elements added in, like hydrogen, sulfur, bromine, chlorine. This list is not the entire list, but some of the common VOCs that are in the atmosphere that have been observed and studied scientifically for their reactions and for their potential risk of health to humans and our ecosystems. The top 6 in different color, the red-orange color, are the ones that have been studied and proven to cause harm to humans. And a couple are carcinogenic, which means they cause cancer if the human is exposed to a certain concentration and duration to these VOCs, these chemical compounds. Now on the right, we have the source of each of the VOCs listed. Now a lot of these sources include both outside natural sources, anthropogenic sources, and also sources inside the house, so interior. And many of the sources listed are very common in human lives. For example, the use of fossil fuel products, gasoline, pesticides, resins, waxes, aerosols, adhesives, any kind of industrial processes, storage tanks, rubber, paints, clean materials, furniture, plywood, all these things humans and our ecosystem interact with on a daily basis. And this is why VOCs can be very harmful, very potent, because they're everywhere. They are in everything and released from generally everything, not only outside in certain areas like landfills, but also inside our homes, inside our houses, inside our living room, our kitchens, how we clean our house, how we furnish our house, how we paint our outside and inside of our house. All these things release VOCs, which can be harmful to our health. VOCs are a primary pollutant. They are emitted directly in the atmosphere from various sources, both natural and man-made. And when they go into the atmosphere as these vapor compounds, they are chemically reactive, and also they react and break down through the presence of sunlight, so photolysis and photochemical and photodissociation. Now these compounds will break down into smaller free radicals, which will then combine chemically with other gases that are already in the atmosphere, nitrogen, oxygen, and other hydrocarbons that are already present in the atmosphere, like CO2, CH4, and produce secondary air pollutants that are generally more environmentally harmful than perhaps primary pollutants are. So we're going to start with the addition of VOCs into the troposphere and the interaction with sunlight, which is the HV, and that's going to produce the breakdown into free radicals, and those will chemically combine with the pre-existing elements and molecules and compounds already in the troposphere, like O2, NO, NO2, and these will produce hydroxyl radicals, tropospheric ozone, secondary organic aerosols, which can be deposited onto the surface as liquid or solid particles, and peroxyl radicals or peroxyl nitrates. And the combination of VOCs and tropospheric ozone, O3, can create photochemical smog, which is a pretty bad environmental pollutant. When discussing any topic in environmental science, it is the relationship and the impact that humans have on our environment, our natural world, our planet, and how the impacts can cause damage to both the environment and also to human health. Now, VOCs that are released from man-made chemicals, man-made materials, or man-made or anthropogenic activities have an impact not only in our atmosphere to create different secondary air pollutants like tropospheric ozone or photochemical smog, which can cause harm to humans. VOCs by themselves, the certain chemical compounds, can cause short-term or acute health issues as well as long-term or chronic health issues. Now, exposure to VOCs on a short-term basis can cause an array of health issues such as irritation to eyes and nose and throat, can cause nausea and vomiting, can cause someone to lose their balance, cause headaches, fatigue, changes in vision, and difficulty breathing. However, if you're exposed to a large concentration over a long time, long duration, which is chronic, there are potential health issues which cover organ damage, damage to the kidneys and the liver, increased risk of cancer, and also issues with the respiratory system. So in general, VOCs can cause health issues to humans, can cause issues with our environment, dry deposition of these VOCs into secondary organic compounds that have condensed. All of these can cause issues both on and inside our bodies. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.